The information contained in this presentation is intended for general informational purposes only. The presentation is not a substitute for a review of the applicable government regulations, codes, OSHA standards, or other regulations, and should not be construed as legal advice or opinion. Specific questions should be referred to the proper regulatory authorities, electrical engineer, licensed electrician, or attorney. 3-wire 120/240 volt single-phase power used in the United States is sometimes incorrectly called two-phase. The proper term is split-phase or 3-wire single-phase. The correct terms include split-phase, 3-wire single-phase, 3-wire 120/240 volt single-phase. The incorrect term is two-phase. Looking at this image, you can see that an entire cycle of the voltage wave, starting at 0, going all the way positive, then back through 0, then all the way negative and back to 0, is taking 1/60th of a second. This waveform is said to be a 60 Hertz voltage waveform. 60 Hertz means that the waveform repeats 60 times per second. This is why the length of one cycle is 1/60th of a second. And as you probably have already guessed, the reason that the waveform is 60 Hertz is because the coils of the generator at the power plant are spun at this rate. This is the standard frequency used for power distribution in the United States. Because the voltage of alternating current can be easily controlled with transformers, this is the type of electricity generated by power stations. The transformers raise the voltage to make it easier to transmit over long distances, then lower the voltage for safer use in homes and buildings. In fact, this is the big advantage that alternating current provides. The fact that it is relatively easy to change the voltage of the power using a device called a transformer, power companies save a great deal of money. This way, using very high voltage to transmit power over long distances. Here is how it works. Let's say that you have a power plant that can produce 1,000,000 watts of power. One way to transmit that power would be to send 1,000,000 amps at 1 volt. Another way to transmit it would be to send 1 amp at 1,000,000 volts. Sending 1 amp requires only a thin wire, and not much of the power is lost to heat during transmission. Sending 1,000,000 amps would require a huge wire and generate a lot of heat, which would be lost during transmission. So power companies convert alternating current to very high voltages for transmission, such as 1,000,000 volts. Then drop it back down to lower voltages for distribution, such as 1,000 volts. And finally down to 120 volts to be used inside. A common generator, something that most people are familiar with, is a good example of how generating stations produce electricity. On the other hand, direct current, DC, which is electricity flowing in a constant direction and or possessing a voltage with constant polarity. DC is the kind of electricity made by a battery with definite positive and negative terminals, or the kind of charge generated by rubbing certain types of material against each other, such as a comb through your hair. This is known as triboelectric charging, a type of contact electrification in which certain materials become electrically charged after they come into frictional contact with a different material. With DC electricity, connecting a wire from the negative terminal of a battery to the positive terminal will cause the negative charged electrons to rush through the wire towards the positive charged side. Direct current systems do not have any moving parts, as in the case of a battery or solar panel. Advantages of direct current include reduction of noise and danger. DC will not interfere with wireless devices or create that annoying humming sound in devices, and is far less lethal than AC. Sometimes a little education can make one more careless than before, as someone feels more comfortable in their knowledge. There is a cardinal firearm safety rule that says, treat every firearm as if it is loaded. That can be applied to working with electricity. Treat all electrical as if it is energized. By making this assumption, you will reduce your chances of an unwelcome surprise. If you make a mistake in plumbing, you might make someone unhappy. Make a mistake in air conditioning, and someone might be uncomfortable. But a mistake with electricity, and you could injure or kill yourself or others. I realize that probably most of you watching this have already been shocked by electricity and obviously have lived to tell about it. Unfortunately, the more that occurs, the more it tends to lower our defenses. Please never take safety for granted and always treat electricity with the respect it deserves. Your life and the life of others may depend on it.